Welcome to Intro to Digital Logic Part 10. In this video, we'll be going over half adders and full adders. We will be using the following dates in this example, so you may want to pause here for a minute just to take in what the outputs will be for these gates. So to begin, let's go over the half adder. The half adder consists of a A and B input tied to an exclusive OR that outputs a S or sum bit, and the A and B inputs are also connected to an AND gate, which outputs a C or carried bit. So let's go over some binary addition to see how this works. If we add 0 plus 0, this equals 0, which is the exclusive OR output, or the sum. If we add 1 plus 0, or 0 plus 1, this equals 1, which is the exclusive OR output again, or the sum output. If we add a 1 plus 1, this equals 0, which is the output for the exclusive OR, or the sum output, and the next bit flips to a 1, which this is the carried bit and is tied to the AND gate output. The flaw of a half adder is that we can only generate a carry output and cannot take a carry input. The full adder can take a carry bit, and the logic diagram is listed on this slide. For your reference, this is hard to look at, so let's look at a block diagram instead. Really, this full adder is two half adders combined with an OR gate to make a full adder. This full adder is a half adder that has an input of A and B, and the carry is hooked into an OR gate, and the sum bit is tied into a input for another half adder. The second half adder also has a B input connected to a carry in bit from a previous operation. This half adder outputs to an OR gate with an output of a carry out. The half adder also outputs a sum bit. Now to explain the binary addition, let's first go over normal addition of 7 plus 9. We would take 7 plus 9, which equals a 6 in the first digit, and then we would carry over a 1 to the second digit. This 1 drops down to give us a 16. So now to do binary addition of the two inputs that have a value of 1 bit each, we get for the first digit the sum of the two bits equals 0. The 1 then gets carried over into the second addition, which is the addition of the carry in plus the A input plus the B input equals the sum. This results in a binary 1 in the second position and a 0 in the first position. Now the full adder is doing the same thing. If there is a carry from a previous digit, it is added to the A and B input to result in a sum digit and a carry out digit. I have listed on this slide a truth table that goes over every variation of a two-variable full adder. So carry in of 0 plus an input A of 0 plus an input B of 0 equals a carry out of 0 and a sum of 0. A carry in of 0 plus a input of 0 plus a B input of 1 equals a carry out of 0 and a sum of 1. A carry in of 1 plus a input of 0 plus a B input of 1 equals a carry out of 1 and a sum of 0. A carry in of 1 plus a input of 1 plus a B input of 1 equals a carry out of 1 and a sum of 1. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. And be sure to check out my Digital Logic playlist.